minus 7 seconds.
Hi! Hi, science guy. Hello. Yes, I was just studying some of my stuff here. I wanted to talk to you about Newton's laws. Newton's law of motion are the 3 laws proposed by Sir Isaac Newton concerning the relationship between force, motion, acceleration, mass, and inertia. Newton's first law states that a body at rest will remain at rest. And a body in motion will remain in motion unless with a constant velocity. Unless acted upon by a force. This law is also known as the law of inertia. Now, Newton's second law states that a force acting on a body is equal to the acceleration of that body times its mass. Expressed mathematically, that's F equals ma, where F is force in newtons, m is the mass of kilograms, and a is the acceleration in meters per second. Newton's third law states that for every action, there is a equal and opposite reaction. Thus, if one body exerts a force F on a second body, the first body also undergoes a force of the same strength, but in the opposite direction. This law lies behind the design of rocket propulsion, in which matter forced out of a burner at the speed creates an equal force driving the rocket forward. Signing off. It's alright.
Shut the fuck up.
Find a quiet place and sit comfortably on the ground with your back straight. Make sure you are in a very comfortable position.
Hey guys, I'm Brandon. As you can see here, from what you saw before, it's Isaac Newton. Newton had 3 laws. Number 1, the law of inertia. Rest will stay at rest, and an object in motion will stay in motion until a force is acted on it. Law number 2, on force and acceleration. Law number 3, action and reaction forces. Newton's first law is inertia. Every object continues in a state of rest, or of motion in a straight line, at a constant speed unless it is compelled to change its state by forces exerted. A force is a push or pull. An example of this is friction. Here, let me show you an example.
Let the bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the
Object at rest stays at rest until acted upon by force.
Newton's second law is the most important. The acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. Acceleration produced depends on the mass that is pushed. More energy to move something heavier has more mass.
Check this out. If Brandon were to push me, it would require a lot less force than if he were to push Glenn. See, I went back further than Glenn did when we got pushed. This is because even though we have the same force exerted on us, I have a smaller mass than Glenn does. Because the masses are different and the forces are the same, the acceleration still is different. My acceleration is greater than Glenn's is because I got pushed back further. All Newton's second law, force equals mass times acceleration.
Newton's final law, action and reaction forces. Every action has a separate but opposite reaction. Just like this. I'm leaning on the tree, and the tree is leaning back at me. For example, fly swatter hits person, person hits fly swatter. I lick the cone licks back. I wipe my face, and my face wipes back.